Hey everyone. So for today's webinar, I'm just going to walk you through the uh, the design and creation of a database for a web application. So the idea is to just touch on a lot of the concepts that you would be learning in the course right now, and just show how you could go about actually building a database that'll be um, useful for whatever application you're making. So the things that I'm going to touch on are basically going to be giving like an overview, um, and then the design of an entity relationship diagram, which is basically one of the ways that you can go about uh, really understanding um, a database for an application. Like it's to me, it's pretty intuitive. It's practical, um, and then one of the more important parts of the entity relationship diagram would be the cardinality. So the relationship between all of the entities, and then from your ERD, how you go about creating the database tables, the database and the tables. And then once you have them, you want to populate them, and then you want to query. And then one of the more important and complex queries that you would do would be a join. And then obviously you may want to delete data from your database. So yeah, I just want to go through this, walk you through each of these um, areas, just so that it becomes quite intuitive and you understand exactly what you're doing when you're going through all the content in the Udacity coursework. Okay, so um, basically an entity relationship diagram or an ERD. Uh, so what this really is a set of tables that allow you to model the database that um, your application will be linked to. So um, you can do this for anything. I think one of the most common ones would be to do um, a a customer with a product and an order. So just think about any shop. You know, you're going to have customers that are purchasing stuff. You're going to have the orders, the specific orders that they make, and then the products that they purchase. So this would be three common tables that any shop would, any shop or online store or anything would have tables like this. And an important thing to just note right now is that the columns and rows in the ERD are inverted from the columns and rows in an actual database table. So in a database table, each row would be an entry in your database. So for example, if we had this over here, then let me just show you in real time. So say you had your customers table. So in your database, right, you would have each of these transpose. So customer ID would be one of your columns. First name would be another one. Last name would be another one, etc. And you'd have all of the columns here, which have information. And then every single row, so let's call this row 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For each of these rows, you would have an actual entry into your database. So, you know, custom ID might be 324. Then the first name might be John, and the last name would be Wolves. And say you had, if you look over here, the next one would be Street. And so say that was Street then this might be, long street. So the important thing to note here is that this over here is called an entity relationship diagram, right? And this is really, really useful just for the design in the planning phase of, when you're building your database. But especially if you're new to this, you may be confused. But essentially, the way that this table looks, it's just it's a conceptual mental model, and from this you build your database tables, and your database tables will have where these look like where each of these entries looks like a row in this table. It's actually just listing all of the sorry, it's just listing all of the actual columns in your real database. So you see that's a column, that's a column, and that's a column. And the rows in your actual database table will each be an entry, So the table is a table of customers. So each of these would be a customer, Another customer here. So that's the first important thing to note. Okay, so that's just I want you to keep in mind. So when you're building an entity relationship diagram, it's almost like mind mapping. What you're actually doing is you're thinking, what is all the information that I actually need to store in my database? So in an online store, you'd want to, for example, you'd want to keep track of all your customers. You'd want to keep track of your orders, and you would want to keep track of all of the products. And then another important thing to note is that these three things that you're keeping track of are going to be related to each other, right? So each customer may or may not make an order, and each order will have at least one product, but it may have many products in it, right? And so if you were doing anything, this is exactly what you would do. If you were designing a database for anything, it would be exactly the same. So for example, if you had, sorry, I'm just looking for my spreadsheet there. If, let's just clear all of this, or we'll just add another spreadsheet. Sorry, another sheet. Okay, so you could have customers, orders, and products, but what you might have is a database of, say you are building something like Twitter, then you might have tweets and users, right? And so this would be the this table over here. Let me move them a bit. This table would have all the details about every single tweet, and this would have all of the details of every single user, or every single person with a Twitter handle. And there would be a relationship between the tweets and the users. Okay, so in the same way that in this example, your customer makes orders, right? And every single order would only have one customer associated with it, and every single product, could every single order will have one or many products in it, and lots of different orders can have the same products. There wouldn't be a direct link between products and customers. You'd have to go through this intermediary, which is the order, right? Did a customer purchase a product in a specific order of his? So an order in this context here is a transaction, So if you went onto Amazon and you purchased 3 things, right? So that would be a single order, right? And then another day you purchased two more things plus the original three things, then your products, three of the products would be common, but your order would be a completely new order. In the same way, if you were designing anything, so for example, if you were designing Twitter, you would have tweets, and every tweet can only be created by one user, right? But a user could have many tweets. So yeah, hopefully I'm getting across quite clearly that the entity relationship diagram is designing the rules behind how your database will work, right? And so how do you actually do that? I'm describing it, but I'm not explaining exactly how you'll do it or what the point of the entity relationship diagram is. So all it is in essence is a table describing each of your database tables, right? And then you would have all of the columns. So each of these rows would be a column in your database table. So basically what you would do is you would say, what are the attributes of this table, a customer? So you might say, what does a customer need for you to accurately represent him in your database? Him or her, you would need a name, first name, a last name, an ID, an address, right? And maybe a contact number, a phone number. And then for an order, how do you accurately describe an order? And in the exact same way, you would need something unique, a primary key, which we'll get to later, and you'd need a whole bunch of other things, right? Where is the order being sent to? Okay. What was the ship date? Right? Now, an important thing just to keep in mind is you are not going to list what was in the order, right? You don't list, so this order, what was, how many things were ordered. You don't put any of that into this table, right? Because of the way in which databases are designed, right? What you would do, though, is you would have a related table which stores all products. And so later on down the line, when you have a database, you would say one of the things that would link these two is you would probably have an you would create an actual order, okay, and that would be, and the order would have some information from. So say an actual let's call it a transaction, not an order, because that's the name of this table, or let's call it a specific order. The specific order would be a query between these two tables, and it would show the so you would list products, and you would list the order ID or the order number. And that's how you would describe a specific order. So yeah, hopefully you understand that. Basically, another example I'm just trying to show you is the tweets. So for example, you might want to find all the tweets by a certain user, right? And that would be a query between these two tables. Select all tweet content. So say you've got, say the fields of this table of content, date of the tweet, and then the user ID, right? And then users would have a name, a user ID, and maybe something else like an age, for example, or let's call it a profile picture. Okay, so if you did a query on all of the tweets that a certain user did, then that's how you'd be able to bring them all up. And that's the kind of thing you'd want to do with your application. So yeah, that's where that's basically why you would do an entity relationship diagram. So how do you actually go about building it? So the first thing you'd want to do is you'd want to list all of the tables that your database wants. And this should be pretty intuitive if you understand the thing that you build. So if it's a shop, you'd have customers, orders, and products. You may have more, but we're just focusing on some of them that may be useful. Then, right, or as the second example, you might have the tweets and users might be your main two databases. I mean, database tables. Okay. So once you've got those, you draw them in your entity relationship diagram, and then you would start listing all of the columns that would be available, or that you'd want, and you want to, you could have 100, but essentially you just want everything that's useful um, for your database. So, you wouldn't start adding stuff in here that isn't related to the customer. And there should be nothing here related to your actual orders. Um, and over here, every order, right, would need a customer. So that's why you might have a customer in here. But we'll get to that right now. So the next thing is, once you've done this, okay, so say you have your 3 tables here, or if we're doing it, well, 2 tables over here, right? Then the most important thing, right, is once you've listed all of the columns, you want to start figuring out how these two are related. And so you might have some rules like each tweet only has one author, which is a user. That seems like something logical. You definitely don't want another, well, a tweet has to be written by only one person, right? In the same way, each order can only be made by one customer. Say you're on Amazon, you wouldn't want yourself to be, if you made an order, you want Amazon to know that you're the person that made the order and nobody else. 2 people couldn't have made the exact same order, right? They may have ordered the same things, but it won't be the same order, right? Because it wasn't made by the same person. So you start to look at all those rules that apply to your database. So looking at the relationships between them, right? Another thing is that a user could have 0 or many tweets, right? So 0 or many tweets per user. So maybe you just created an account, but you didn't actually tweet, right? So then you have 0 tweets, right? But you could have thousands and thousands of tweets, or just one, So that would be another rule. So if we look back at this ERD, you see that another rule would be that an order can't have 0 products, right? So a user might have 0 tweets, but an order can't have 0 products. Okay. So now to really, instill and enforce these relationships, right? Because they're pretty important. When you start writing data into the database, you don't want to start getting problems like multiple users all creating the same order. That's when your database starts to break. So that's why you want to do this before you even create your first table, and that's the real point of this entity relationship diagram, to really describe, first of all of the content, and then how, or all of the data, and how the data is related to each other. So what you have is you have a set of rules called the cardinality, right? And so every single database would be drawn together with these lines, okay? And these lines would describe the relationship, right? So the possible relationships is 1, many, 1 and only 1, 0 or 1, 1 or many, and 0 and many. And so hopefully, like I've already touched on them, but you may see what I mean. So if it's a tweet, right, a tweet can have 0, a user could have 0 or many tweets, right? So the relationship between the users table and the tweets table, we would draw a line over here, and the line would have the symbol that we just saw over here next to the tweets, because a user could have 0. So the line joining the users and the tweets would have 0 or many tweets, right? It would be different for the line between your order and your product, right? Because each order would need at least one product. You can't have zero. You can't have an order with zero products, right? Then it's not an order. So if you have one and only one, for example, right, that would be the relationship between your order and your customer. You know, as I've said many times, uh, an order can only be made by one and only one customer. It can't be one or many. It can't be zero or many. It can't be zero or one. It has to be one. There will always be one customer making each order. And so basically, you would draw in these, basically use these symbols to describe the relationship on this line between each of your tables in your database. Okay, so if you were able to do that, okay, you eventually would end up with a large entity relationship diagram. So for example, here I just grabbed one off the net, which is for hockey. I don't know too much about hockey. I don't really know anything. But it is pretty illustrative. So you would have a collection of games, right? Or rounds, sorry, then an actual game, and then a team and a user who's keeping track of all of this. So I guess this is like a I think one of those like fantasy leagues or whatever. And then you would have all the stats from each of the rounds, and then you'd have a team, and you'd have information related to each of these users, right? And as you can see here, each of these has a line relating to it. So, for example, a hockey game can be related to one and only one round, right? But a round can have one or many games. Okay, so if we go back and we look at those, the cardinality, the choices we have, of course, it'll take you a bit of time to memorize these, but that's the one. This chicken's feet is a many. The two lines is one and only one, 0 and 1 because of the 0 and the 1. The 1 plus the crow's feet, chicken feet, I'm not too sure, is one or many. So basically, you have a choice of 6 different types of relationships, okay? And when you've got a choice like 0 or 1, right, what you do is you, on the inside, so if here's your line and here's a table and here's another table, on the inside part is where you put the minimum, and where on the outside is where you put the max. And the way you do it, honestly, I think it just requires practice. Sometimes I'm putting the wrong relationship. So or I used to put, say, for example, the relationship between customers and orders is very specific, right? A customer can have lots of orders, but an order can only have one customer. So the way to remember it generally is that your customer, the relationship between your customer and your order is you say a sentence out loud. So you say, how many customers can an order have? And the answer is one and only one, right? So there will be the two lines over here, and then vice versa on this side. Okay, so in the end, what you have is something like this. Okay, now this is a perfect description of your database, right? It cannot work any other way, right? Now, once you have this, if you use software, I think there's quite a lot of different types of software like this, but if you use Lucid Charts, I found it quite useful. I'm not going to, plug it or anything. Say it's great, but essentially from here it's actually terrible right now if you're learning because you want to do everything manually so that you really get the hang of it. But once you're building big databases, it's quite cool because there is software like this available where you're basically, once you've got your entity relationship diagram down, it means you really understand how the database should work. And straight from here, this builds the basically it would and I just wanted to show you quickly, but I'm not too sure where it is right now. But sorry, essentially what this can do is you can output your actual yeah, well, I suppose it doesn't really matter because you want to be doing this manually. But from the entity relationship diagram, uh, this software will build your actual database creation code, right? The SQL. So that being said, let's go straight to that now. So once you've designed your entity relationship diagram and you've implemented the cardinality, which is the relationships, then you want to actually create a database. So this would have been covered in some of the Udacity courses, but basically you want to start, you would essentially, if you're just using plain old SQL, you would create your database, right? And this is different depending on whether it's Postgres or SQLite or MySQL. But basically, you'd create the database, right? And then you would start creating tables, and this would be the instruction: create table. Um, and when you create a table, right, the actual format and syntax, I won't go through each of these. You could find this all, 100 different places on the net. But I'm just walking you through the process quickly of how you would do this. So you would create a table, let's say. So sorry, just making sure that I don't do this as efficiently as possible for you guys. So say for example, in this little example that we had here, right? So we've designed this, then we would say we called this Twitter. So then you would say create database, and we could call it Twitter, and that would be your SQL command to create your actual database. And then maybe you want to create your first actual table within your Twitter database. And so let's call it tweets. Okay. So create table tweets. Okay. And then you would describe it. Okay. And so inside here, it's incredibly intuitive, but you would have column one, and it would be, we called it content. Usually you would put the unique ID. And maybe, sorry, let me just pause for a second and go back to this entity relationship diagram, right? So an important thing to note is that whenever you build one of these, right, the way in which you relate different tables to each other is through something incredibly unique that every single table has, right? So every single table will have a primary key. So basically that is a unique identifier. And the important thing is that if we go back to this image over here, okay, if there's not, what you really want for every single entry in your database is something to uniquely identify it. So how do you separate orders or look them up, right? And so what you do is you have a primary key, right? And then in all the tables that are related to it, you would reference that primary key, and that would be a foreign key, right? So maybe the easiest way to describe this, sorry, is that if you have your primary key in your customer table, it will be your customer ID. And in your product table, it would be your product ID. Okay. And so in your order, right? So you may have a custom ID, and this would now be a foreign key, okay, referencing the primary key of another table. And that's really how the relationships are built, okay? So every single table needs a primary key, and every single entry in a table needs a primary key, okay? And the important thing is that if there's nothing unique, you know you've done something wrong with your database. Okay. So yeah, just keep that in mind. Okay. While we go through an example quickly. So once we've created our database called Twitter, then we want to create our table, which is tweets, right? And we want to list all of these. So the user ID, the only reason it is there is to uniquely identify the tweet. Okay. So if we're doing this, we would have column one, and let's call it content. Okay. So you would say content for column one. And then once you've got sorry, I'm just thinking about how to do this. The best way to explain it to you would be you have column one and then the type of data. So the data type, right? Column two and the data type. And you would go along listing every single one of your IDs, each of the columns in your table, and then right at the bottom. There are other ways of doing it, but one way of doing this is you say primary key and you'd say column one, right? And this is how you would create a table in your database, right? Here, this is how you'd create your your database, and then this is how you'd create your tweets table. And you would do this for each of the tables, then you do another one. Well, but before we get to that, this is just showing you exactly what you would put in here, but let's put more realistic information in here. So you wouldn't call it column one. I was just describing how you do this. So we'll use the words we've got here. So we'd say, let's call it user ID. I had UID, but let's call it user ID. It's more descriptive. So what you might have is user user ID is the name of the column in your table, and the data type, we'll call it an integer, right? Okay. And then over here, you could put your primary key, right? But we're going to put it at the bottom. But just note that you can do it either way. And then the next column is called date. So then we just say date. And depending on which database you're using, so let me just, for example, look up SQLite data type. And so just so I can show you what I'm reading, basically you don't have, for SQLite, doesn't have a storage class set aside for storing dates. Right? You would just use text, right? Or you could use any of them, you can see. But so let's store the date as a string like this. Okay, so we will use text. So if we go back, I'm just arbitrarily using SQLite, but I'll swap. It doesn't really matter. I'm just trying to show you roughly how you do this. So the date would be text. Okay, and then right at the bottom, once you've listed all of your columns, you indicate which is private or primary or foreign keys. So we put here user ID. Okay. So once you've done this, right, then you have a database. Okay. So the next thing that you want to do is, once you've created your database, is you'd want to, populate it. So the main way you do that is just using the insert into. So it's a simple command. Let me just close this. We don't need that. And so just like so this is the SQL syntax to create a database and then to create a table. I'll just delete this so we have some space. Next, say you want to, we'll put this at the bottom here. So now say you have your database, right? And you've got your tweets and you've got your users. Once you have designed the entity relationship diagram, then what your application will do is when someone fills in a form, say for example, where they creating a tweet, then you want to populate it, right? So you would say insert into and whichever the table name, so it was tweets that we had, okay, and then you don't have to do it this way, but in the beginning it's the most intuitive way to do it. So you name the columns, okay, and then you provide the data. So insert into tweets, and we have content, date, UID. So we have content, date, UID. We changed it, I think, to user ID. Okay. Insert into tweets, and those are the three columns. Then you put the values. So you say values, and you enter the values. And content would have been text. So we'll say this is my tweet. Okay. Then next we said was the date, but when we looked up SQLite, there were a range of different ways, but we're going to use text. So we say, 2 May 2019 as text, and then the user ID. Now the user ID will usually by most databases be added automatically. So what I will do actually is leave this out. You could just put there, say, if this was the first entry into the database, you could put the ID as 1, but we'll leave it blank like that, and it will know to add an ID, a primary key based on the way that we set up the table. Okay, so essentially that's how you'll be putting data in. And then the last important thing that you want to be doing, that you will be doing all the time, is just querying the data. So you want to maybe select all of the tweets that were written by someone. So when you click on this on Twitter and you click on a person, you'll scroll down and you'll see the tweets. So basically Twitter is grabbing all of the tweets from a certain person. So they're doing a query. So the way that you build a query is with the select clause. So, well, not clause, the select statement, right? And so essentially what that would do is, so just as you insert insert it into tweets, you'll select from tweets. So if you want to, so for example, you'd say select, and say you just want the content. So then you'd say select content from tweets. Okay, and then you may have a this would give you every single tweet on Twitter, which is, select content from tweets. It would just show you every single tweet, which is just insane, right? So you want to narrow it down a bit. Or with another example here, say you want all the orders where the customer ID is equal to a specific customer, right? So if you want to see, so on Amazon, when you check your orders, right, that query would be a query just like we're doing. Amazon would do that with their database, and they would say select. Well, sorry, I don't want to use two examples at the same time. So go back to Twitter. You'd say select content from tweets and say you want it from a specific person. So you'd say where UID, user ID, is equal to, and then you say, so say we had user one, right? And the result of this query is would provide you all of the tweets from a specific person, right? And the same with Amazon. If you select, so if you were doing this to find all your orders, when you click on your Amazon dashboard and you press and you click your orders, it'll send something similar to the Amazon's database, and it will say select order, or let's say it would select items. It will select more, so it'll say item, name, image, price. So you can select a few things. From orders is the name of that table. Orders, and sorry, there's no comma. Where, and then this is where you've got a condition, and you would say user ID is equal to whatever your Amazon ID is, and you probably may not know it, or it could be your email address. And so, okay, and that would be your customer ID. And this is how the database would bring back to you everything that you ordered, right? And so often what you want to do is you want to get a lot of data from a lot of different tables, and that's where you'd use joins. So if I delete all of this, I just wanted to show you the very last thing. In the course, the Udacity course you're doing, there's going to be an example that uses courses, funny enough. And so basically what you might have is you might have a students table, right? Just as we've got a customer table and order table and a product table, you might want to be choosing from two of them, right? Or many of them. So basically, say you had a students and a courses table. So you wanted to find a student's name and a course name. So basically you wanted to return all of the courses that each student was doing, right? Then the way you would do it, and in a particular year, right? Then you would say select name, course name, because that's the two columns that you want of information. From students, that's your first table, join courses, that's your other table, where the start date, and start date would have to be common to both of them. Okay, so that's how you would start to do more complicated queries. So in essence, hopefully, I've been able to give you a rough overview of how you go from using all the information that you're busy learning in the Udacity courses, and you can conceptually link this up to a real application that you would be building, where you start with an entity relationship diagram, which really helps with you understanding intuitively what you're doing. You list all of the columns that you would want. You don't forget that even though they're rows here, these are the columns in your database. Right? You assign the relationships to them. You make sure an order, for example, cannot have more than one customer making that order, but a product could be in lots of orders, and an order could have one or more products. You can't have an order with no products. And from there, you build your you include your cardinality, and from here you start building your database. But when you build the database, you're just carrying out a collection of commands because all your rules are already written in your entity relationship diagram. And then hopefully you can see that no matter what you're using, your database is interacted with populating and querying simply with these types of queries. So hopefully that gives you a good overview and maybe a bit of practical insight, showing that it's kind of intuitive and kind of simple how even massive relational databases work, say in Twitter or Amazon. And yeah, let me know if you have any questions. Cool, thanks.